is the second video in a series, and we'll be looking at section 12.2 that deals with prisms and also helping us find surface areas and lateral areas. So the first thing we have to figure out, moving on from 12.1, is what a right prism is and what an obtuse prism is. So before you, I have two types of prisms. If we look at their bases, they have five sides or pentagon bases. So if that's the case, I can call them pentagonal prisms. But as you can see, the prism on the right is a little off kilter, and when it's off kilter, it's called an obtuse prism. But when it's all straight, it's called a right prism. And the key distinction, and you would be able to see it in the textbook clearer, is that if a prism is right, it means that any lateral edge can be used as a representation for its height. So if you look at the right prism, we can see that I can label the sides h to represent the height of this prism, but on the left prism, which is an obtuse prism, I can't. I have to get a separate measure of the vertical height from the top first base to the bottom base. And so the below I write the key difference. In the right prism, the lateral edge can be used as the altitude or height, and in an obtuse prism, the lateral edge cannot be used as altitude or height. So if you see a question with an obtuse prism, you might have to make some adjustments. So the first thing they get to in section 12.2 is what a lateral area is. And a lateral area simply is the sum of the sum of the area of all the lateral sides of a solid figure. Mm, mm, mm. Yes, it's the sum of all the area of all the lateral sides of a solid figure. So in a prism, this means adding up all the areas of all sides excluding the bases. So I have a diagram here called figure A, and I've gone ahead and labeled it, but the idea is to build up to what you're getting at. So this is a triangular prism with a top two bases at the bottom, that's a triangle STU, and at the top that's triangle PQR. And I labeled the length of line PR as A, the length of line PQ as C, the length of line QR as B, and the height as RU. So it is on a right triangular prism. So, and the lateral sides are the rectangles QTRU, PQST, and behind PRSU. Okay, so we have three lateral sides, two bases, and they make a right triangular prism. And so, yeah, if we wanted to find the lateral area, we would need to sum up all the areas of all the lateral sides. So let's call this lateral side area, sorry, that we're trying to figure out as L, which I've labeled here. And we write L as the area of the first lateral side, which is rectangle Q RTU, the second lateral side, which is rectangle PQST, and the third lateral side, which is rectangle PRSU. So if we write what the values are, because the area of a rectangle is the length times its width. Sorry, yes. So we write the first one QRTU. We can see that the top is a B and the bottom is also a B. So that length will be B and the width will be H. So we write it as B times H. And the second one, likewise, we write it as C is A times H. And the last one is A times H. If we group by the common factors, we can reduce this to L, which is a lateral area, equals to the sum of A, B, and C multiplied by H, which is the height. But if we look particularly as A plus B and C, we can see that those are the sum of all the sides of the base triangle for this right triangular prism. And all the sides, if you add them up, that is also known as the perimeter of the base. So moving on to theorem 12.1, what they're trying to tell us is that if we have a prism, and we know the perimeter of the basis, and we know the altitude or height h, and we can find the lateral area, and we can write that as the lateral area being multiplying the perimeter of a single base times the height or altitude. And one thing we should notice as well is that if it's a triangular obtuse prism, like so I've drawn a obtuse triangular prism here, the length, sorry, the formula is still L equals P times H. And I drew these two prisms to scale just so you can see it. Because even though technically the sides, the lateral edges are now longer, the height still stays the same because I'm measuring the height by the shortest perpendicular distance from the top to the bottom. So we can see that. And the next thing we go to is the surface area. And so the surface area differs from the lateral area because we want to find the surface area of everything. So we are adding the sum of all the lateral sides, which is the lateral area, to also to the summing that with the areas of the base, the two bases. So let me just go over that again. The surface area of any solid figure is the sum of the areas of all the faces of a polyhedron. And in a prism, this is the sum of all the lateral sides and bases. So we know that a prism has two bases from 12.1, and so the surface area will be the sum of all the lateral sides, L, plus the area of the first base, B, and plus the area of the second base, B. And I gave them the same letter to signify them because the two bases always have to be the same. They can't be different, so they get the same measurement. So I can simplify this into a formula base by writing that S is equals to the lateral area plus which is L plus B, and I can simplify that a little bit as S is equals to L plus 2B, and that's where we need to know. So this is like a checkpoint, and you just have to remember that if I'm asking for the lateral area, I'm asking of the sum of the area of all the lateral sides. And if I'm asking for the surface area, I now want you to include the bases. In a pyramid, that'll be two bases. In a prism, that'll be two bases, and in a pyramid, that'll be a single base. And now that I have S is equal to L plus 2B, I can bring back the formula of what L is, which is the perimeter times H, which with the heights, which is how we get to that point in the textbook. So we have the surface area S will be equals to the perimeter times height that makes up the lateral area added to the 2 times the area of a single base. So this is simplified in theorem 12.2. So if we have a triangular prism again, which is also a right triangular prism, and so we can make the sides the height, the perimeter of this base will be P, the h will be the altitude and height, and the lateral area we found earlier, and the b will be the area of a single base. And then we can write the surface area S as equals to L plus 2b and equals to pH plus 2b. Okay, so one example is the figure A that I'm going to give you now. So in figure A, we have a triangular prism, which is also right, and we have three pieces of information. We have one side of the um, of the base is 3, another side is 4, and we have the height at 6. I have given you the markings to show you that the triangle that makes up the base is right angled, and also that the sides are right angled as well, which makes you know that they're rectangles. So I want you to find I want to find the lateral area and surface area. And so because the lateral area makes up the surface area, we try and always find the lateral area first. And so we go to that tiny tidbit of information. that the lateral area is equals to the perimeter of the base multiplied by the height slash altitude. So we start taking that information in. The first things first, what is the height? We look at the side, that is clearly 6. So we put 6 down. What is the perimeter? So this is a little tricky. It's a right angled triangle. We have 4, we have 3, but we don't know the final side. So we just put X. I write that in green, but we don't know that. But we need to find the perimeter of that triangle, and the perimeter of a triangle is adding up all the sides. So we know that the triangle PQR, the sum of all its sides, would be 3 plus 4 plus X. So how do we find X? Because it's a right angled triangle, the Pythagorean theorem applies. So if we use a Pythagorean theorem, which says that a squared plus b squared equals c squared, we can write it out and solve for x to make sure to find 5. So we know that x is 5. So we can go back to our equation for the perimeter, put 5 in, and we can get the sum of all the sides to equal 12. So we have our p. And earlier we found our h, so we just put that together to find our lateral area, L. So that's equals to pH, which is equals to 12 times 6, which if you put it into your calculators, is 72. And now that we found the lateral area, now we need to find the surface area. So we go back to that fundamental formula, which is S is equals to L plus 2B. And this is why I put this there, because instead of starting again by making it S equals to pH plus 2B, we can just leave it simply as S equals L because we've already found what the lateral area is. So we just put that in for that part. And then all that's left is to find a B, which is the area of a single base. And we know what we're looking at is the base of this triangular prism is the area of triangle PQR, or the area of triangle STU. But because those two bases are the same, whichever one we pick, it doesn't really matter. So we pick the top one and we go with that. And the area of a triangle is half times the base times the height. So we put everything we know. So if we look at it's a right angle triangle. So if we can make either PQ or QR the base, but if we do that, the other has to be the height. So the way I went this way was to make 3 the base and 4 the height. So you put that in, that's 6. So we have what our B is, and we have our L. So we find S, which is the surface area. So we go back to the formula. S will now be equals to L plus 2B, which is equals to 72 plus 2 times 6, which is 12. We add that together, that is 84. So your turn. And so I made this one, and so just try and do it, and I'll go through a solution in just a jiffy. So this is going to be a right rectangular prism. So a right rectangular prism, and one of the sides is 6, one of the sides is 4, one of the sides is 7. And so I want you to find the lateral area as well as the surface area. So pause this video and take a crack at this. And once you're done, press play and I'll go through the solutions. Thank you, guys. Okay, so solutions. So first things first, the fact that I've said it's a right rectangular prism, it means that the base has to be rectangular, and we know that it's right. And because it's right, whatever I select as my lateral side edge, that edge is going to be the height of this prism. So I'm not going to change the orientation of this diagram. I mean, technically, because all the sides are rectangular, you can make anyone the base, but just to keep things simple, I'm going to make PSRQ my base and TUVW my base as well. And so the sides of those are 7 and 4. And I make QV, RW, ST, PQ as my lateral edges. And so I know by orienting it this way, I'm picking my bases clearly in keeping with the definition of this prism that my height is going to be 6, and the perimeter of my base will be the perimeter of rectangle PQRS, which is just adding up all the sides of that rectangle, which is 7 plus 4 plus 7 plus 4, which is 25. Is that correct? Uh, No, that should be 26. I do apologize. hmm hmm Okay, so that's 26. And so in that case, I have to now find the lateral area. So I found the perimeter, and now I have the height, and so I work it out. So that will be 26 times 6, which gives me a score of 138. 136, I believe, sorry. Mhm. 30, 156, pardon me. And so that's going to be the answer. And then the next part is that we find the surface area.